So we're back. Today we are talking about Unit 9, Lesson 3, and we're going to talk about Venn diagrams today, and hopefully you've seen these before, but today we're going to talk about specifically how to use it to determine probabilities. And before we get started with Venn diagrams, we have to talk about set notation. This is going to be some new notation that you've probably never seen before. And the first thing we need to do is define what a set is. And a set is just a list of stuff. So, for example, I might say set A, and then I'm going to list some numbers in set A. So maybe 1, 2, 3, 4, 5. Okay. So those are, let me move this arrow. Those are the objects in set A, and then maybe I'll list set B. Set B is maybe 2, 4, 6, and 8. Okay. So two sets. Set A has 5 items. Set B has 4 items. And so we could talk about what these sets have in common. They have some numbers in common, what they don't have in common. And we have mathematical ways of notating that that are just shorthand, essentially. So the first one I want to teach you is called a union. Just like a union between two people is when two people get together and they have all this stuff in common and they have more from maybe all their friends join. I'm being like cheesy here, but this is what a union is. It's where two things come together and everything merges. So a union between two sets would be everything in both sets. Okay, so a union between sets includes everything in all sets. Okay, that's called a union. And the way that we would notate that is we would say the union of A and B, that symbol means union. So the union of A and B, and it's a kind of a big U, and in this case we would list everything in both sets. And you want to go in order if we're dealing with numbers. So 1, 2, 3, 4, 5. Okay, bye Jesse. I'm recording a video. You're in the video now. 1, 2, 3, 4, 5, and then we also have 6 and 8. So the union of A and B is everything in both sets. So easy enough, right? We also are going to talk today about intersection. Okay. The intersection of two sets is only the items that are in common. Whoops, that's supposed to say is. Only the items that are in common. So if we're talking about the intersection of A and B, much like when two streets come together, the intersection is, part of the street that's in both streets. If we're talking about the intersection, and that's going to be that symbol is an upside down U. The intersection of A and B includes only the items that are in common. So we're looking for items that are in both sets. A 1 is only in set A, but a 2 is in both sets. 3 is only in set A, 4 is in both sets. Excuse me. A 5 is only in set A, 6 is only in set B, and 8 is only in set B. So the only items that are in the intersection are 2 and 4. And there's one more symbol, and it's this backwards slash. And that means in A, but not in B. So for these sets, A not B, we would say, equals, and we would want to list all of the items that are in set A, but not in set B. So in this case, 1 is in set A, but not in B. 2, we're not going to put that because it's in both sets. A 3 is in set A, but not B. 4 is in both sets. 5 is in set A, but not in B. And we're not worried about the stuff that's in B, but not A. Although I suppose we could list that. B, not A, would be those items in B that are not in A. So that would be, let's see, 2 is in A, 4 is in A, but 6 is not, and 8 is not. Okay, so that is the basic idea behind set notation. There are 3 symbols: union, intersection, and then this symbol, which is sort of not. Okay, not. So what I'm going to do is give you an example. I'm going to have you work this example out and submit your answers into Edpuzzle just to make sure you get the basic idea here. So example 1, I'm going to give you 2 more sets. Let's do set X. Set X, we'll say 5, 7, 10, and 14. And set Y is going to have 5, 7, 10, 14, 17. Okay. And what I would like for you to do first is find the union of X and Y. Then I'd like you to find the intersection of X and Y. And then I'd like you to find X but not Y. So go ahead and pause the video, work those out, submit your answers to Edpuzzle. Feel free to work with the people around you because you've got other people probably in the same spot as you. And then when you're ready, submit your answers to see if you got them right. Okay, so the union of X and Y is everything in both sets. So we've got 5, 7, 10, 14. And then the only thing I haven't listed is 17. So those are all the numbers in both sets. That's the union of the sets, everything coming together. The intersection, well, those are the items that are in both sets. And for this set, that's 5, 7, 10, and 14. Those are the items in both sets. X not Y, those are the items in X that are not in Y. And the thing here, it's kind of weird, but it's empty. So you just leave it like this. It's an empty set because everything in X is also in Y. So nothing is going to be in X not Y. So hopefully you feel okay about set notation. The point of this set notation is that it's going to help us to solve probability problems when we work with Venn diagrams. So moving along, new page, we're going to do a story problem, and this problem is going to take up a bit of space in your notes, so just be ready for that. Okay, so in my 5th period class, we've got 32 students. So this is example 2. In period 5, there are 32 students, okay? $18 students take Spanish. $14 take a class at Sabin-Schellenberg Center, and 10 do both. So take a moment and get that down. And now we're going to make some letters that represent events here. So we're going to let S be the event takes Spanish. So take a moment and write that down. And we're going to let C be the event class at Sabin-Schellenberg Center. So here's what we want to be able to do. I want to be able to ask you, what's the probability that if I randomly pick a student out of my 5th period geometry class, they take Spanish? Or what's the probability that they don't take Spanish or a class at Sabin-Schellenberg Center? And so in order to be able to work out those probabilities, we really need to know how many students take one, how many students take another, how many students take both. And so that's why a Venn diagram is really, really helpful here. So the first thing we're going to do is complete a Venn diagram. In math, when you make a Venn diagram, the first thing you have to do is draw the universe. And the universe is a rectangle. Did you know that? So we're going to call that the universe. That means basically this is all students in period 5 are going to be in this rectangle somewhere. Now within the universe, within period 5, and if you want to, you can even write period 5. Okay, within there, we're going to draw a Venn diagram. We get one circle for each event. So that circle is going to be event S. That circle is going to be event C. So the students in this circle take Spanish. The students in this circle take a class at Sabin-Schellenberg. And we're going to try to place all 32 students in this universe somewhere where they belong. So this is harder than it looks because what we know is that 18 students take Spanish, but we cannot put the number 18 right here because there are some who take both. And the students who take both have to go in the middle because they need to be in both circles. 10 students do both, and that's really the only number I can directly put down. 10 students take both, so I'm putting 10 here. These students are in the Spanish circle, and they're in the Sabin-Schellenberg circle. Now, for the rest of this, I have to do a little bit of thinking because 18 students take Spanish, which means if I think about my Spanish bubble, I'm going to make it purple just so we can kind of look at it on its own. If I look at the Spanish bubble, I can only have 18 students there. 10 of them are already here. So how many students go here is the question. And I hope you can figure out that it's 8. Okay, so this works because I've got 18 students in the Spanish circle, but 10 of those students do both. And so now, let me grab a different color. We're going to do something similar for the Sabin-Schellenberg circle. So in the Sabin-Schellenberg circle, which I'm going to make orange, I need a total of 14 students because 14 students take a class there. But I already have 10 students in the circle. They just also happen to take Spanish. So that only leaves 4 students, right, who take a class exclusively at Sabin-Schellenberg but don't take a Spanish class. So what I want to do for just a minute before we finish is label what each circle means. So what I'd like you to do is kind of say there are 4 students who take C but not S. Okay? They take a class at Sabin-Schellenberg but they don't take a Spanish class. There are 8 students who take a Spanish class but not a Sabin-Schellenberg class. There are 10 students in the intersection. So this is both. Okay, this is the intersection, students who do both S and C. Now, what's weird is that there are 32 students in the class, and these numbers do not add up to 32. So let's see what they do add up to. We've got 8 who only take Spanish, 10 who take both, 4 who only take a class at Sabin-Schellenberg, if I add that together, what is that? 18, 19, 20, 21, 22 students, but there are 32 students in the class. So I've got 10 students who don't go in the Venn diagram, right? I have 10 students who don't take Spanish and who don't take a class at SSC. Those students need to go in the universe, they just don't go in the Venn diagram. And so we're going to just put a number 10 down here. Those are 10 students who take neither Spanish nor a class at Sabin-Schellenberg. Okay, so what we've done is we've taken this, which seemed really simple, and put it in this super complicated diagram, but it's worth doing because now we can answer all sorts of probability questions. So the question now is, if I select a student at random, I want to know what is the probability that they take Spanish. Let me put it this way. What's the probability that they're in the intersection, right? So these are students who take both Spanish and a class at SCC. So let's actually write that down. Take both. That's what it means. So if I pick a kid at random for my 5th period class, what's the probability that they take both? Well, we have 10 students in the intersection out of how many total students? 32. And then we can reduce that fraction. We could convert it into a percent if we wanted to. What's the probability of just Spanish? This means what's the probability that if I pick a kid out of my class at random, they take Spanish, period. It means they take Spanish. Okay, well, if they take Spanish, they're going to be in this purple circle. So how many students are in the purple circle? 8 plus 10. 18 take Spanish out of 32. What is the probability that they take Sabin-Schellenberg but not Spanish? So take a minute and look at the Venn diagram and see if you can figure that one out. What's the probability that if I pick a student at random, they take a class at Sabin-Schellenberg but they don't take Spanish? So here I'm looking for students who are only in the C bubble, but not in the S bubble. So I'm only looking at those 4 students. So 4 out of 32 is 1/8. And I think we'll do maybe one more. That looks like suck. Oh well. So I want you to think about what this means, the union of S and C. What does that mean? So the union of S and C means students who take Spanish or a class at SSC. We're bringing all these students together who are in the Venn diagram. So students who take Spanish, students who take a class at SSC, or both. And so to do that, we're basically adding up all the numbers in the Venn diagram. We have 8 plus 10 plus 4, which we already worked out, is 22. So that would be 22 out of 32. Okay. This is really challenging. It's really hard. And I think that's enough notes. I don't think I want to do another example, but you have your homework to do on page 5 has 5 of these examples. I think what I would like to do right now is actually do number 1 with you, especially since I'm not there to help you with your homework. So if you can pause the video at this point, here's what I'd like you to do. First, I want you to write a summary, and then I'm going to have you submit that summary on Edpuzzle. After you submit your summary, the video is going to continue, and we're going to look at page 5 together, number 1. So go ahead and write your summary, submit it, then take out your homework packet, turn to page 5, and then continue the video so we can go through that example together. Okay. So hopefully you're back, and we're talking about page 5, number 1. Number 1 is a little funky, so let's read it together. It says, the letters of the word equation are written on cards and placed in a hat. I don't know why anyone would do that, but whatever. One card is drawn at random. X is the event of vowel. So let's put X right here. Okay, and anything in that bubble is going to be a vowel. Y is the event, a letter of the word note. So this bubble is going to be Y. That means if we have a letter and it's in the word note, it's got to go in the Y bubble. So this is a bit bizarre. These are the letters that we're working with. So these letters are placed in a hat. So what we need to do is go through one by one. We've got these letters, and we're going to figure out where they go. If you want, if it's helpful, you can kind of write vowel here, and you can write N-O-T-E here. Okay, so let's go through them. E. Is E a vowel? Yes, it is. So we know it needs to go, I'm going to color these circles. We know it's going to need to go in the orange circle. The question is, does it go here or does it go here? E is also in the word note. It's right there. So E belongs in both bubbles, the orange and the green, because it's a vowel and it's in the word note. So E goes in the intersection. It's in both sets. Got the E. Let's think about the Q. So the Q, it's not a vowel. It's not in the word note. So it belongs in the universe, but it does not belong in the Venn diagram. So I hope you remember where we put it. We'll just stick it in the corner. Okay, it does not go in the Venn diagram at all, but it does need to go in the universe. So we're done with Q. U. U is a vowel. Hooray! It goes in the orange circle. U is not a letter of the word note. So see if you can figure out where the U is going to go. All right, there we are. Okay, it's got to go in the orange circle, but it cannot go in the green circle. It's not in the intersection. A. A is a vowel. A is not in the word note. See if you can figure out where it goes. Over here with the U. T. Take a minute on your own and see if you can figure out where the T goes. Okay. So T is not a vowel, so it cannot go in the orange circle. T is in the word note, so it should go in the green circle. We just have to make sure it goes over here so that it doesn't go into the intersection. All right, I. Actually, here's what I want you to do. See if you can figure out where the last 3 letters go, and then check in with me. Okay. So I think I did this right. It's a little weird. E, Q, U, A, T, I, O, N. Everything in the orange circle is a vowel. Everything in the green circle is in the word note, and poor Q is just out here in the universe. So now that we have our Venn diagram done, we can give these probabilities. The probability of X just simply means, like, I'm going to grab a letter at random. What's the probability that it's a vowel? Because that's what the event X is. So in the orange circle total, I've got A, E, I, O, and U, right? 5 vowels. And then in the word equation, I've got 1, 2, 3, 4, 5, 6, 7, 8 letters. So the probability is 5 over 8. Q counts as a possible outcome because it is in the word equation. It's just not in the Venn diagram. So the probability of Y means the probability of getting a letter in the word note. And so we've got 4 letters in the word note out of 8 letters in the word equation. So that's 1/2. Here we're doing the intersection of x and y, and so I want you to see if you can figure that out on your own. That means what letters are in both events, what letters are both vowels and in the word note, and what's the probability of picking one at random. So see if you can figure that out. We've got 2 letters there in the intersection out of 8 total letters in the universe. 1 out of 4. And in the universe, obviously I mean of this problem. And then lastly, the union. So the union means what's the probability that I get a letter that's in both sets? No, that's not right. In one of the sets, right? In the Venn diagram, basically. So in the Venn diagram, I've got 1, 2, 3, 4, 5, 6, 7. So this is essentially asking what's the probability that if you draw a letter, you get a vowel or a letter in the word note, right? You've got 7 chances out of 8 of that happening. So this problem is a little funky. I think you'll find the rest of them easier on this page, but your assignment today is to complete this page, page 5, and also there's one exercise for you to do on Khan Academy. It just has to do with set notation. Again, make sure you get 80% or higher on that skill, and hopefully you can get both of those things done today. That's it.